Hello everybody, my name is Hussam and this is project 3 for medical robotics course. In this project we will use the optimization methods to find the transformation matrix between these two robots. Let's begin with the GUI. From this panel, the absolute panel for end effectors, I can change the end effector value of robot 1, 2, and I can change the base values for each robot. Also, I can change the t-guess for or the initial guess for the optimization function. Let's see for robot 1 if I can just make a slight change for robot 1. As you see, the end effector has been changed. I can also change the base of the robot, or let's make it for robot 2. I can change it. Okay, as you see, robot 2 has been moved. From this translation panel, I can translate the end effector of the robots. This is for X, this is for robot 2, and I can also translate the base. As you see, I've translated base 2 and I can go back. And this slider controls the step size for the translation. These two panels here shows the end effector values for each robot relative to its base. From these scrolls here, I can control the joints for each robot. This is a control for robot 1, and I can also control, for example, robot 2. And as you see here, the end effector relative value is changing automatically. Okay, now let's go with the optimization function. For the optimization function, we have to let the end effectors of the robots touching to create pairs of relative values and find the transformation between them. We can do that either manually or automatically. I created this button to find automatically the points of touching, and as you see here, it's trying to find touching points. Okay, and now we have 7 touching points, and we can find t based on these touching points. As you see here, before we begin, this is the calculated t, and this is what we expect from the optimization function. Okay, let's now see the optimization. Okay, this is the result of the optimization. As you see, it's almost the same with the calculated one, and this is here the error value. Okay, also I added these two buttons here. I can save my list or my touching points to a file, for example. So I can make t.m and save it. Also, I can from here load the points from the desktop. As you see here, I've loaded the points again. Okay, let's now try to find t for a different configuration. Let's shift the value or shift the base for x1, and as you can see here, it's now we have a different optimization method. Let's change t-guess, for example. Let's make it far away, and let's make this to, for example, and set. Okay, now let's test, let's create points of touching. Okay, this is a point, second point, 5, 6. Okay, now we have a touching points. Let's find t between them. Okay, here's the optimization result for the second configuration. It's also quite similar to the calculated one. Now I will talk about the 3D slicer and the segmentation process. Hello everybody, I'm gonna show you now how to use 3D slicer to build a 3D model for the brain. This is a model for the brain using MRI images, and I'm gonna use the editor to segment the brain part from the image and build a 3D model from it. First, I will use the threshold effect in my painting tool to guide the painting brush to segment the brain correctly. Let's just adjust the threshold to find Yeah, this is good. For let's now use it for the paint, and let's use the paint effect, or we can use the level tracing effect. It is a good one, and as you see, just select a region here. Oh, maybe it's not good. Let's try the drawing effect, the paint effect tool. Okay, the paint effect tool works perfectly, detecting the segmenting the brain. Okay, I will do that for all the slices I have. Then I will build the 3 model. Okay, now after I've selected segmented the brain from the image, I will use make model effect and apply. I will name it tissue. It's applying now for the model. Okay, and here is the model we got. This is the brain segmented from the image, but you can see here the noise we have created while selecting from the segmentation. For that, I will use use the erode effect, and this one will remove these, for example, these small dots supplied for 4 neighbors. Okay, it reduced now the error. If we another time, yep, it now reduced the error. Let's go back to the create model and let's create a model. Let's go tissue 2, apply. Okay, it's creating the model now. Okay, now let's see the models and just delete the previous model. Now this is the model we got after the erosion. The noise has been removed and this is the brain. Okay, now I will demonstrate the use of MATLAB bridge and a 3D slicer. Uh, let's go first by the MATLAB commander. Let's try a simple command to plot the sine function from 0 to pi over set simple command to pi. Okay, and y equal sine of x. Let's show a figure now, and let's plot for x and y. Okay, let's apply the command. Okay, here you see the figure for the sine function. Now I will demonstrate the use of MATLAB module generator. I have used here, as you seen previously, the threshold filter, and I can take that code to MATLAB. Let's go with MATLAB now. The module generator. Let's name the module MR, for example, MRI test, and let's create a generate module. And let's see the function. As you have seen here, the script for MATLAB has been created. It takes the image and it makes a threshold for the image for the images. Okay.